Hello everyone. It is our pleasure to show you to the work for PES-GM 2023 event. The CV presentation title is Solar Generation Forecast Using Generalized Linear Model with Multiple Time Series Speakers. 1. Joan Martinez Lopez, Department of Computer Sciences, Faculty of Informatics, Camagüey University, Camagüey City, 74650, Cuba. Joan.Martinez at reduc.edu.cu. 2. Julio Madera, Department of Computer Sciences, Faculty of Informatics, Camagüey University, Camagüey City, 74650, Cuba. 3. Ansel Rodriguez, Unidad de Transferencia Tecnológica Centro de Investigación Científica y de Educación Superior de Ensenada, CICESEUT. 3. Tepic, Mexico. 4. José M. Fernández, Department of Computer Sciences, Faculty of Informatics, Camagüey University, Camagüey City, 74650, Cuba. Abstract. This presentation aims to discuss the use and benefits of a generalized linear model with multiple time series for solar generation forecast. We will discuss how it provides greater precision compared to other models due to its ability to utilize multiple relevant metrics in its computations and how this can be used by power companies to adjust their energy generating output accordingly in order to optimize production without wasting resources. Solar power forecasting is the process of gathering and analyzing data to predict solar power generation on various time horizons to mitigate the impact of solar intermittency. Solar power forecasts are used for efficient management of the electric grid and power trading. Several approaches were used to solar power forecasting, such as advanced optimization techniques and artificial intelligence, for example, artificial neural network, (AN), deep neural network, (DNN), and generalized linear model. Competition outline energy resources forecasting is increasingly important in current and future power and energy systems. Due to the high uncertainty of generation based on renewable energy sources, which results from their dependence on weather conditions, such as wind speed or solar intensity, the need to develop suitable solutions to deal with such variability increases considerably. Relevant effort is being put on the development of energy consumption and generation forecasting methods, able to deal with different forecasting circumstances, e.g., the prediction time horizon, the available data, the frequency of data, or even the quality of data measurements. The main conclusion is that different methods are more suitable for different prediction circumstances, and it is not clear that a certain method can outperform all others in all situations. This competition fosters the benchmarking of artificial intelligence methods for solar generation forecasting. To build and refine the forecasting models, a dataset comprising 3 years of historical data is already available, as well as the dataset comprising the previous 4 months before the week to be forecasted. In order to solve this challenge, we developed the following procedure. 1. Create a dataset using the information of 3 years of historical data for training of the GLM. 2. Create a dataset using the information of the previous 4 months before the week to be forecasted for testing the GLM. 3. Create multiple time series variables using the previous datasets. 4. Run the GLM with the time series variables as inputs. Generalized Linear Model, GLM, is a flexible generalization of ordinary linear regression. The GLM generalizes linear regression by allowing the linear model to be related to the response variable via a link function and by allowing the magnitude of the variance of each measurement to be a function of its predicted value. Generalized linear models were formulated by John Nelder and Robert Wedderburn as a way of unifying various other statistical models, including linear regression, logistic regression, and Poisson regression. Time series data, also referred to as time-stamped data, is a sequence of data points indexed in time order. These data points typically consist of successive measurements made from the same source over a fixed time interval and are used to track change over time. Moreover, multiple time series, MTS, forecasting refers to training many time series models and making predictions. With the execution of the GLM algorithm on the time series data, The solar power forecast was performed, where an R2 of 0.98 was obtained. The generated power is shown in the following figures. Next, with this trained model, the solar generation forecast for each hour of a full week, 168 values, was calculated.